Okay, we're up to module 10 of ENSA, which is network management. Okay, so in the chapter we're going to do CDP, which is Cisco Discovery Protocol. Then we're going to do LLDP, which is basically an open standard version of CDP. Because of course Cisco Discovery Protocol is Cisco proprietary. Then there's NTP, Network Time Protocol, and then there's SNMP, which is Simple Network Management Protocol, and then there's Syslog, which is basically getting your log messages to a centralized server instead of having to go to the console of your devices, and router and switch file maintenance, followed by iOS image management. Okay, so device discovery with CDP. So CDP is a Cisco proprietary layer 2 protocol that is used to gather information about Cisco devices which share the same data link. CDP is media and protocol independent and runs on all Cisco devices such as routers, switches and access servers. The device sends periodic CDP advertisements to connected devices. These advertisements share information about the type of device that is discovered, the name of the devices, and the number and types of interfaces on those devices. As you can see, there are messages sent between the devices. For Cisco devices, CDP is enabled by default I think that's old information actually. To verify the status of CDP and display information about CDP, there's a show CDP command. If you wish to actually see neighbor information, it shows CDP neighbors. To disable CDP on specific interface, you can no CDP enable. And that will just disable on a particular interface. So, you know, maybe an internet-facing interface, that'd be smart. CDP is still enabled on the device, however, no more CDP advertisements will be sent out of that interface. To enable CDP on specific interface, you do CDP enable, as would logically follow. To enable CDP globally for all supported interfaces on the device, you would do CDP run in global config mode. CDP can be disabled for all interfaces on the device by doing, of course, no CDP run. You can do show CDP interface, and that will tell you the interfaces that are actively running CDP, and it will give you the status. All right, so as I said, to actually get neighbor information, it's show CDP neighbors. And so show CDP neighbors is a generic one where you actually get basically one line per neighbor, and just tells you the local interface on R1 that's connected to, how long until we would erase that information, what capability the other device is, so S and I, which mean it is actually a switch, and I means it's a smarter switch that runs IGMP, which is for multicasting, and it tells us that it's a 3560 model switch, and on that switch it's on fast Ethernet 0/5 that is connected to G001 on R1. And so it gives you a good summary, but you can actually put detail on the end of that and get more information, which I'm assuming what the next slide is. And so it will actually give you, it's nearly a screen full of details about that device. And so as you can see, you get IP addresses as well, which is another good information for mapping devices. And yeah, so yeah, certainly some good information. Now LLDP, which is Link Layer Discovery Protocol, is a vendor-neutral neighbor discovery protocol similar to CDP, but of course, yeah, not proprietary. And so it works with network devices such as router switches and wireless LAN access points. This protocol advertises its identity and capabilities to other devices and receives the information from a physically connected layer 2 device. Of course, they both need to be running LLDP. So to configure LLDP, it can be enabled by default, but it often isn't. To enable LLDP globally on a Cisco device, you do LLDP run as opposed to CDP run. And of course, to disable it on that entire device, it's no LLDP run. LLDP will be configured on specific interfaces. However, LLDP must be configured separately to transmit and receive LLDP packets. And so as you can see here, we've got LLDP transmit and LLDP receive. And then there's show LLDP to actually have a look at the information, or the status, sorry. And so, of course, the transmit and receive is done on a particular interface. All right, so you can do show LLDP neighbours and you get very similar information to what we got from CDP. It's just that we're doing it on switch 1. It's got a switch 2 as well as R1 connected to it. And so basically you get the same information, capability, route. B, I'm assuming, would be bridge. Yeah, so of course, switch is just a multi-port bridge. So again, there's show LLDP neighbours detail where you get roughly that screen full of information. And so versions of operating systems among many other things. So certainly some good useful information. All right, now NTP is Network Time Protocol. And so the software clock on a router or switch starts when the system boots. It is primary source of time for that system. It is important to synchronise the time across all devices on the network. When the time is not synchronised between devices, it will be impossible to determine the order of events and the cause of an event. Typically, the date and time settings on a router or switch can be set by using one or two methods. You can manually type in the date and time. So with that clock set command that's shown down below, that's nice. Well, it works, but it's not nice in that you have to do it on every device. And so every time there's a power outage or whatever it might be, you would actually need to do that on all your devices. So routers and switches don't have the battery backup with the CMOS running that keeps track of the time. And so it basically zeroes out to the beginning of the universe, of course, which is when Cisco was founded. And so, yeah, the time is not right. And so having an NTP server that you can actually synchronize your routers and switches to makes your messages from those devices meaningful. Okay, so as a network grows, it becomes difficult to ensure all the infrastructure devices are operating with synchronized time using the manual method. It doesn't scale, in other words. A better solution is to configure NTP on the network. This protocol allows routers on the network to synchronize their time settings with an NTP server, which provides more consistent time settings. NTP can be set up to synchronize to a private master clock, or it can synchronize to a publicly available NTP server on the internet. NTP uses UDP port 123 and is documented in RFC 1305. All right, so basically, how is NTP is organised in a hierarchical system, and so each level of this hierarchical system is called a stratum. The stratum level is defined as the number of hops from an authoritative source. The synchronised time is distributed across the network by using NTP. The maximum hop count is 15, or stratum 15. So the lowest, stratum 16 is the lowest stratum level, indicates the device is unsynchronized. So basically, an authoritative time source, you can actually use GPS for that because time is very important to GPS, and so it's also deemed to be a reliable time source. But of course, there's often things like atomic clocks and the like that will allow you to do that as well. And so, as you can see, stratum 1 got its time source from that reliable time source, and then of course that one learned it from that, and so on, and then that's how your stratums lie. And so stratum 0, these authoritative time sources are high precision timekeeping devices, assumed to be accurate and with little or no delay associated with them. So stratum 1 devices are directly connected to those authoritative time sources. They act as a primary network time standard. Stratum 2 and lower are connected to stratum 1 devices through network connections. So stratum 2 devices, such as NTP clients, synchronize their time by using the NTP packets from stratum 1 servers. They can also act as a server for stratum 3 devices. Time servers on the same stratum can be configured to act as a peer with other time servers on the same stratum level for backup or verification of time. That's what those cross-size ways ones were. Now, before NTP is configured on the network, the show clock command displays the current time on the software clock. With the detail option, notice that the time source is user configuration. That means that the time was manually typed in, basically, with that command we showed earlier. Now, NTP server and an IP address, of course, will, in global config mode, configure the device to actually synchronize its time with that server. And so this is R1 has been synchronized to a time server. To verify the time source is set to NTP, you do that clock detail again, and you'll notice that the time source is now NTP as opposed to user configuration. Now, you can actually do show NTP associations. And so you can use that to verify that R1 is synchronized with NTP server such and such. Notice that R1 is synchronized with the Stratum 1 NTP server, which is synchronized with the GPS clock. The show NTP status command displays that R1 is now Stratum 2 device that is synchronized with NTP server such and such. So yes, very close to an authoritative source. The clock on S1 is configured to synchronize to R1 with the NTP server command, same command in global config mode. And so as you'll see that the router is of course Stratum 2 and the switch is Stratum 3. All right, so SNMP, or Simple Network Management Protocol. So it was developed to allow administrators to manage nodes on an IP network and enables network administrators to monitor and manage network performance, find and solve network problems, and plan for network growth. So it's an application layer protocol that provides a message format for communication between managers and agents. The SNMP system consists of 3 elements. And so you've got an SNMP manager, so that's that centralized workstation that's basically gathering all the information. SNMP agents are basically the devices that are being managed, and so basically it's a small piece of software running on each of those devices. And a management information base is basically information about what that device, what those agents, the devices that the agents are running on, so it knows what information can be is useful for that particular device. So SNMP defines how management information is exchanged between network management applications and management agents. SNMP manager polls the agents and queries the MIB for SNMP agents on port 161. And SNMP agents send any SNMP traps to an SNMP manager on 162. So basically, there's two ways that the SNMP managers can gather information. The normal one is by queries. And so that's initiated by the SNMP manager device itself. And so it queries the device, asking for status and other such things. While you can also set, now that's the way it originally worked. And then later on they thought, well, if we've got a device that's talking SNMP, if something happens, it should send information to the server as it happens, so you get more up-to-date information. And so that's what a trap is when the actual agent initiates the communication as opposed to the server. Trapping events, basically. All right, so SNMP Manager is part of a network management system. The SNMP Manager can collect information for an SNMP agent by using the get command, so that's where you ask for information, and can change configurations on an agent by using the set action. And so there's often, you'll actually have community strings for read-only and read-write. So read-only would be used to get information. The read-write is used to set information. SNMP agents can forward information directly to a network manager by using traps, as I said. An SNMP agent and MIB reside on an SNMP client devices. MIBs store data about the device and operational statistics and are meant to be available to authenticated remote users. SNMP agent is responsible for providing access to the local MIB. Okay, So SNMP agents that reside on managed devices collect and store information about the device and its operation locally in the MIB. The SNMP manager then uses the SNMP agent to access information within the MIB. The two primary SNMP manager requests are get and set. In addition, configuration, a set can cause an action to occur, like restarting a router. And so there's get request, retrieves a value. Get next request, retrieves a value from a variable within a table. Get bulk request, retrieves large blocks of data, such as multiple rows in that table. Get response replies to get request and get next requests. And then a set request, of course, stores a different value in a specific variable. SNMP agent responds to SNMP manager requests as follows. Get an MIB variable. So the SNMP agent performs this function in response to a get request. And so the agent retrieves a value requested or of the requested MIB variable and responds to the network manager with that value. And when the set, of course, an agent performs this function in response to a set request PDU. And so basically SNMP agent changes the value of the MIB variable to the value specified by the network manager. An SNMP agent reply to a set request includes new settings in the device. Now, agent traps. Traps are unsolicited messages alerting the SNMP manager to a condition or event on the network. Trap-directed notifications reduce network and agent resources by eliminating the need for some SNMP polling requests, which of course is the GET request. The figure illustrates the use of a trap to alert network administrator that interface G000 has failed. The network management software server software can send the network administrator a text message pop-up window on an NMS software or turn the router icon red in the GUI. And so, as you can see, the interface has gone down for whatever reason, and so it sends the message to the network management station. All right, there's multiple versions of SNMP. Now, versions 1 and 2, people often call them security not my problem. That we're not secure at all. But anyway, legacy. So SNMP 1 is legacy. It was done in RFC 1157, uses simple community string based authentication method, should not be used due to security risks. So version 2C uses a simple community string based authentication method, provides for bulk retrieval options as well as more detailed error messages. SNMP version 3 is where they actually got some decent encryption, and so uses username authentication, provides data protection using HMAC, either MD5 or SHA, and uses encryption for DES, 3DES or AES, so much better solution. I think there is a version 4 out now as well. Okay, so SNMP versions 1 and 2 use community strings that control access to the MIB. Community strings are plain text passwords, and so they authenticate access to MIB objects. And so, as I said, there's a read-only and a read-write community strings. So, of course, read-only is where you can access variable values, but you can't change them, hence the read-only name. And so, of course, read-write is where you can actually change settings. To view or set MIB variables, the user must specify the appropriate community string for read or write access. All right, so MIB organises variables hierarchically. Formally, the MIB defines each variable as an object ID. OIDs uniquely identify managed objects, then organises them based on RFC standards in a hierarchy of OIDs, usually as a tree. The MIB tree for any given device includes some branches with variables common to many networking devices and some branches with variables specific to that particular device or vendor. RFCs define some common public variables. Most devices implement these MIB variables. In addition, networking equipment vendors like Cisco can define their own private branches of the tree to accommodate new variables specific to their devices. And so basically, the figure shows the portion of an MIB structure defined by Cisco. Note how the OID can be described in words or numbers to help locate a particular variable in the tree. OIDs belonging to Cisco are numbered as follows: ISO, which is 1, then 3 for DoD, 6 for Internet, 1 private, Enterprise, and then Cisco. And so, in other words, that's the structure of it all. And so if you follow these down there, that's how you get this string here. So SNMP can be used to observe CPU utilization over a period of time by polling devices. CPU statistics can be compiled on the NMS and graphed. This creates a baseline for the network administrator. The data is retrieved via the SNMP GET utility issued on the network management server. Using the SNMP GET utility, you can manually retrieve real-time data or have NMS run a report. This report will give you a period of time that you could use the data to get the average. So certainly good for planning and other such things. So an object navigator, and so again, that's where those OID strings sort of come in. And so SNMP GET utility gives some insight into the basic mechanics of how it works. However, working with a long MIB variable names like example can be problematic for the average user. More commonly, the network operations staff uses a network management product with an easy-to-use GUI, which makes the entire MIB data variable naming transparent to the user. SNMP Navigator on Cisco website allows the network administrator to research details about a particular OID. Okay, now over to Syslog. So again, this is another centralized system, so you don't have to go to individual devices. So it uses UDP port 514 to send event notification messages across IP networks to event message collectors, as shown in the figure. And so the Syslog logging service provides 3 primary functions. And so the ability to gather logging information for monitoring and troubleshooting, the ability to select the type of logging information that is captured, the ability to specify the destinations of captured Syslog messages. Now, the Syslog protocol starts by sending system messages and debug output to a local logging process. Syslog configuration may send these messages across the network to an external Syslog server where they can be retrieved without needing to access the actual device. Alternatively, they can be sent to an internal buffer. Messages sent to the internal buffer only are viewed through the CLI on the device. The network administrator may specify that only certain messages of system messages be sent to various destinations. Popular destinations for Syslog servers include the following. So the logging buffer, which of course is the local solution. And so if you've ever logged into a router that's been running for a long time, you may actually get a whole pile of Syslog messages before you can actually sort of interact with the router. And so once you connect, it will normally go to the console line. You can configure a device so that they will go to a terminal line, which is of course a VTY. Then of course a Syslog server is the centralized solution. Now, Cisco devices produce Syslog messages as a result of network events. Every Syslog message contains a severity level and a facility. So basically, the smaller numerical levels are more critical Syslog alarms. The severity level of the messages can be set to control where each type of message is displayed, i.e. the console or the other destinations. The complete list of Syslog levels is shown in the table. So basically, level 0 is an emergency. System unusable, that message may not get through. It might be, the device might be dying as you speak. And so you won't get those messages very often. While with debugging messages, you'll get them all the time. And so basically many people go for either level 6 or 5 or maybe 4. So that's normally the level you go to. And so I've got to admit, I normally go 5 if I'm doing anything, but anyway. And so, yeah, informational and debugging, well, that's just often too much. If you've got lots of devices, you don't want to be doing that. So in addition to specifying the severity, Syslog messages also contain information on the facility. So in other words, what part of the router is going bad. So Syslog facilities are service identifiers that identify and categorize system state data for error and event messaging reporting. The logging facility options that are available are specific to the networking device. Some common Syslog message facilities reported on iOS routers include IP, OSPF, system operating system, IP security, and interface IP. Okay, so by default, the format of Syslog messages on iOS software is as follows: facility, severity, and a mnemonic, which is basically just a shortened word to help you. For example, sample output on the Cisco switch for an Ether channel link changing state to up is link 3 up down, interface port channel 1, and then change state to up. And so here the facility is link, and the severity level is 3, and the mnemonic is up and down. And then you've got your information after that, or description. All right, so how do we configure all this? So by default, log messages are not timestamped. Log messages should be timestamped so that when they are sent to another destination, such as a Syslog server, there is a record of when the message was generated. Use the command service timestamps log date time to force the logged events to display the date and time. And so, of course, you'd want to have NTP running first, but yes. And so that's the command there, service timestamps log date time. And so you'll notice before that was done, when you do shutdown, it gives you the information, but it doesn't give you a timestamp. But here, after you've done this, it will actually give you a timestamp, and then it will give you the information. So it is certainly more useful, and especially once you've got them on a server or quite possibly hundreds of messages a day, that of course does put some order to it all. All right, router and switch file maintenance. So the router file systems, so the Cisco iOS file systems allows the administrator to navigate to different directories and list the direct files in a directory. The administrator can also create subdirectories in flash, memory, or on a disk. The directories available depend on the device. And so the example displays the output of the show file systems command, which lists all of the available file systems on a Cisco 4221 router. The asterisk indicates the current default file system. The pound sign indicates a bootable disk. Both of these are assigned to the flash file system by default. And so, yeah, of course, that's normally what kind of file system you're using. Now, of course, because flash is the default file system, if you do a dir command, it will list the contents of flash. Of special interest is the last listing. This is the name of the current iOS file image that is running in RAM. And so you'll note that it's integrated services router 4200. And then from there, it gives you universal K9. So K9 just means it supports encryption, and then version information. And so, of course, these are other files that will be on there. So different devices, of course, will have different files for different reasons. To view the contents of NVRAM, you must change to the current default file system by using the cd command. And then from there, you'll notice that if you do a dir, you'll get whatever's in NVRAM. Now, startup config, of course, is the major thing we normally find there. But private config can be for your encryption keys and things like that as well. And so there can be other things as well. But again, much the same. It depends on the device, what has what, and what it supports and what's been configured. So with a Cisco 2960 switch flash file system, you can copy configuration files and archive, upload and download software images. Command to view the file systems catalog is show file systems. And so again, now, yeah, so basically flash again is the default system. Now, use a text file to create a backup of a configuration. I think we went through this in semester 1 as well, but anyway. And so you can actually use your terminal software to actually create a log. And so, of course, a log of what's happened on the screen. And so you turn that on, you save it to a file somewhere, and then you do show running config, and it will, of course, go to the screen, and of course, it will also go to that log file. And then you then close that log, and then from there, you can actually then get the file. Now, that's a bit of a convoluted way to do it, but it is certainly a solution. Now, a configuration can be copied from a file and then be directly pasted onto a device. The file will require editing to ensure that encrypted passwords are in plain text and that non-command text such as more and OS messages are removed. In addition, you may want to add enable and configure terminal to the beginning of the file. Instead of copying and pasting, a configuration can be restored from a text file by using TerraTerm. When using TerraTerm, the steps are as such, but copy and pasting will work well. Another thing you've got to think of if you're using a config file from a text file is that you need to put a no shutdown in all the interfaces that you want up, because there will be a shutdown command if it's booted without a config in every interface. Now, of course, I've demonstrated this many a time just by using cut and paste. That's my preferred process. Now, there are other ways you can actually back up a config file. And so in this case, we're actually copying it to a TFTP server. So TFTP, of course, is Trivial File Transfer Protocol. And so basically, you can do copy running config to TFTP. It will then prompt you what IP address is that TFTP server. And then it will also ask you to give a name for that config file, and it will normally, by default, use, because as you can see, the host name dash config. But of course, here we're putting a timestamp on it as well, just to make it a little more useful. So that certainly is another solution you can use to do a config file. Now, on your modern routers, there are often USB ports. Now, one of them is often used for the console port, while another one can actually be used as your storage. And so basically, you can plug in a flash drive, and that will be extra storage for you. So the USB flash feature provides an optional secondary storage capability and an additional boot device. Sorry, USB ports on the 4321 router are shown in the figure. You use the dir command to view the contents of the USB flash drive. So you can basically do show file systems, and it will tell you what it is. So as I said, you can do show file systems to command to verify the USB drive is there and confirm its name. It will often be USB flash 0. And so from there, you can copy run to USB flash 0, and that will send you a copy of that running config to the flash. And so that's another way you can back up things. And again, it will ask you for a file name. And so, yeah, it's another solution that you can use. So you can actually do dir USB flash 0, and it will show you what files are on there. To restore the configuration with a USB drive, it will be necessary to edit the USB R1 file with a text editor. Assuming the file name is R1 config, you need to copy it. All right, password recovery procedures. Now, basically, sometimes you'll either forget your password or maybe make a typo when you type it in. Or maybe it's, you've been appointed a new admin person and you haven't gotten all the passwords for your devices, so you might need to do this password recovery procedure. So passwords on devices are used to prevent unauthorized access. For encrypted passwords such as enable secret passwords, the passwords must be replaced after recovery. Depending on the device, the detailed procedure for password recovery varies. However, all password recovery procedures follow the same principles. Now, this is basically enter ROM monitor mode. Now, this is for a router. Enter ROM monitor mode. So basically, you can hit Control Break during boot with a console cable installed. It's the only way you can do it. And you need to do a hard reboot. So you turn the device off and turn the device back on again. And within 60 seconds, you hit the control break, and then you will go into remote monitor mode. Then you can actually change the configuration register. And so it's sort of like how you can change the boot preferences of a computer by playing with CMOS settings. Well, this is much the same way, but it's in binary. And one of the setting you need to do is actually tell the router to ignore the startup config. So then you boot the router, which it hasn't mentioned there. And then, of course, because it's ignored the startup config, it's ignored the password settings as well. And so then you go into privileged exec mode just by typing enable, and then you do that copy startup config to running config. So basically you've then loaded the startup config, but of course you're already in privileged exec mode, so you're there. So then of course you need to change whatever passwords you need to, so as when you close out, you'll actually know what the password is. And of course, once you've changed the password, you've only changed it in the running config, so you need to, of course, save it onto the startup config. Now, you will also need to change that configuration register back to the standard setting so that it will not ignore the startup config. And then, of course, you reload the device. So, step one, you enter ROM monitor mode. All right. By using the break sequence, as I said, control break. And so basically you can see that you get a different prompt. It's ROM monitoring. One, it'll actually go up every time you hit enter for whatever reason. Will actually the number will increment by 1. And then from there, conf reg will change the configure register. Now the default one is normally 2102. And so the 2142 is just changed 1 bit. And so from there, that 1 bit says ignore the startup config. And so that's basically the process. So normally it's 2102, and so we changed it to 2142. And so that's for 1941. Most routers are very similar. But you might want to actually do show version before you do all this, to actually, because one of the entries it tells you is the configuration configuration register value. So you might want to record that first. And then, of course, you need to boot the router. As you can see previously, this was in ROM monitor mode. You then hit reset to actually reboot the device. Now you go in, as you can see, the prompt is router. And so you go into enable mode, then you do the copy run start, and then it applies. So it applies the startup config to the running config, and so you'll notice the prompt has changed to R1. It's configured now. Of course, now you need to go in and change all your passwords. So enable secret, of course, is the first one you think of. But of course, you might need to change the console passwords as well and things like that. So then you do your, as I said, change your config register back to the default setting, and then you save your configuration. And so that just allows it to boot normally from here on in. Of course, you do know the settings now. Now with switches, it's a little different in that the break sequence is actually started by holding the system button when the switch starts. And then there's often extra little commands you got to type in before you get into a full ROM monitor mode. Now you can't, there's no config register on a switch. So what you need to do is actually rename the startup config file to be a different name. So you might put -old on the end of the file name. So you rename the file. And then when it boots, it won't find the startup config file. It will just find nothing. And so it will boot as if there's no config. And so that's your way around. Okay, iOS management. I think this is the last topic from this chapter. All right. So much the same as you can copy a config file to a TFTP server, you can also copy your iOS file to a TFTP server. And that's probably one of the first things you should do when you get a new router, is to get a backup copy of the operating system, just in case it gets trashed for whatever reason. So Cisco iOS software images and configuration files can be stored on a central TFTP server. This helps to control the number of iOS images and the revisions for those iOS images, as well as configuration files that must be maintained. Production internetworks usually span wide areas and contain multiple routers. For any network, it is a good practice to keep a backup copy of the iOS software image in case the system image on the router becomes corrupted or accidentally erased. We all make mistakes. Widely distributed routers need a source or backup location for the iOS software images. Using a network TFTP server allows image and configuration uploads and downloads over the network. The network TFTP server can be another router, or it can be a workstation or a host system. To maintain a network operations with a minimum downtime, it is necessary to have procedures in place for backing up of iOS images. This allows the network administrators to quickly copy an image back to a router in case of a corrupted or erased image. And so basically, you should have a TFTP server set up. And so, of course, the first thing you do is you ping it to make sure you've got connectivity. Then you verify the image size in Flash. And then you copy this image to the TFTP server. Now the command is copy flash TFTP, and that will again will prompt you for the address. You can actually do copy source destination and have it all in one thing, and so you could actually do copy, the file name in Flash. So you do flash colon and then the file name. And then you can do destination TFTP colon // and then the address and give it a file name and different file name if you like. But yeah, it all does work quite nicely. And so, as I said, you can do it simply as, and so this is actually going in the opposite direction of the example, copy from TFTP to Flash. And so to ping again, so this is if the device has had a corrupted operating system, or maybe this is a newer version of iOS, one way or the other. And so, so first thing you should do is make sure you know what the size of the Flash file is that you're going to copy. Well, sorry, the iOS file that you're going to copy. And then, of course, you need to make sure there's enough room on the device. And so you might actually need to delete the old version if it's an upgrade, or just make sure that there's enough space. And so show Flash will tell you how much space is available. And then so copy TFTP Flash, and then it'll ask you for addressing and file names. And of course, this one you have to type in, but I normally would actually I'd have the file name with me and just paste it in personally, just so that I don't have to type it in and make a typo. And then once you've done that name, it actually puts it in square brackets as saying, well, if you want to keep the name the same, you just hit enter. So then we'll transfer it. There's normally a lot more exclamation marks than that, but it will actually go through and copy, and then you can boot from it, reboot the machine and boot from it. The boot system command. During startup, the bootstrap code passes the startup configuration file in NVRAM for the boot system commands that specify the name and location of Cisco iOS software image to load. Several boot system commands can be entered in sequence to provide a fault-tolerant boot plan. If there is no boot system commands in the configuration, the router defaults to loading the first valid iOS image it finds in Flash. To upgrade to the copied iOS file after that image is saved on the flash memory of the router, configure the router to load the new image by using that boot system command. And so, of course, you need to do a copy run start to get that to stay. So this would be required if you've got more than one iOS file on the router, if it's got enough storage. You could do this one first, and then you could do the old one as a second option. You can also, if you've got that TFTP server set up, you can actually do a boot system and then TFTP:// IP address / and then the file name, and it will actually copy the file across the network, and that can be a backup process during boot as well. All right, that's the end of the module. So what did we talk about? So we spoke about CDP and LLDP. So of course, ways you can discover neighbouring devices. Now, one thing I don't think was mentioned in the curriculum at all, or the slides there, is that these can be a bit of a security risk, and that's why it's often off by default with the newer versions of iOS. And so if you want it to run, you've actually got to do that CDP run command or LLDP run command. The problem with them is that there's no encryption in the messages that are sent. And so, yeah, it's plain text. And so while very handy for you to map a network, it's also very handy if people can intercept those files to actually map your network. So it helps their reconnaissance of your network nicely, which is not a nice thing, but anyway. All right, so of course, NTP, very useful if you're going to have your devices talking to a centralized server for either Syslog or SNMP or both. Having a reliable time source for your devices is handy, and so NTP is a good way to do that. And so you can actually set up Windows servers, Linux servers, and most servers as an NTP server. So you don't. So what often you would do is you would have your server maybe checking up with an external NTP server that you rely on, that you trust, and then from there, all of your other devices can then talk to your Windows server or your server on your network, talking to the rest of the world. Now, SNMP, of course, is Simple Network Management Protocol, and that's where you can either find out information or even change settings on devices. So version 3 is a much more secure solution. So Syslog, of course, is where you can just send your console messages to a server, a centralized point, so you don't have to log into the devices. How often would you log into a router if you didn't need to? So basically, having that centralized server is a useful way that you can actually get information and find out the status of things. You don't have to rely on your staff ringing up saying the network's not working. You look like a proactive person who knows what's going on, which is a good image to be putting forward. Now, of course, the file system, of course, is where both operating system files as well as config and sometimes other files as well is stored. And so being able to navigate around that is certainly of use. And so, of course, having backups of your files as well is a good plan. So both your config files and your operating system files should be backed up somehow or other. So you can use TFTP. You can maybe do it through the actual console or the terminal program itself. And of course, you can use USB, TFTP, FTP. There's a whole lot of options there available. And so you should have backups of these things. And so there is the Cisco logo. And so I'll see you again later for Chapter 11. Have a good one.